PU2 champions, welcome back to the Brahmastra series, and in today's video we are going to discuss all the important questions from the chapter Chemical Kinetics. Why this video is important? Because in this video I have collected questions from the model question papers of 25-26, question bank of 25-26 and some very important MCQ questions also. Okay, so let's get started, and if you're able to solve these all questions, then this chapter is done for you for your final exams. Okay, so let's see first of all what is the blueprint or what is the marking scheme of this particular chapter for your final exams. So in total the chemical kinetics has a weightage of 12 marks. And how is this 12 marks divided? So you will be getting one very short answer question, 2 marker 1 question you will get, and 3 marker 3 questions you will get. Okay, one out of them will be theory and 2 questions will be the numerical problems. Okay, so 3 into 3 9 here, 10 11 and 12 here. Okay, so now let's see the questions from the model question papers of 25 and 26. Okay, so I'll start with, there were 3 model question papers, so I'll start with 1, then 2, then 3. So we'll see the first question. So this is a, I'll say MCQ question of model question paper 1. Okay, and the question number is question number 15. You can check it from your model question paper also. The following results have been obtained during the kinetic study of the reaction. Choose the correct option for the rate equation for the above reaction. Now to find the rate equation, what we can assume is, let us assume that rate is equal to K into A to the power of X and B to the power of Y. Okay, now what we can do is we will assume that constant A is constant here. Okay, concentration of A is constant. Now if concentration of A is constant, and what we are doing with concentration of B has become 4 times, right? And if you see here, the concentration of C, means the rate of production of C has also become 4 times, means that I can say with respect to B, if it is a first order reaction. Okay, so Y will be equal to 1. Now let's talk about when I have concentration of B is constant. Okay, you are changing with A. Now here you have doubled the concentration, and what has happened to the rate? So if you see, it has become 4 times, means with respect to A the reaction is like X value will be equal to 2. So I will have Ka square B1, that is my option number C here. Okay, now moving to the next one. For the, so now it is a 2 marker question. For the reaction H2 plus I2 gives you 2HI, draw the diagram showing the plot of potential energy versus the reaction coordinate to explain the role of activated complex in a reaction. To explain the role of activated complex. Now if you see, this is the diagram. Here you have seen H2 plus I2 are the reactants, and then when you provide activation energy, it gets converted to an activated complex. And how does this activated complex looks? It is actually like this. Okay, and then after that the reaction, this bond forms, this bond breaks, and we get 2HI. Clear? So this is the diagram you have to draw. Now coming to 3 marker question, mention 3 factors that affect the rate of a chemical reaction. You have concentration, temperature and catalyst. Now we'll go to the numerical questions of this one. The first order rate constant at 600 Kelvin is 2 into 10 to the power of minus 5, right? So let us see, temperature is how much? 600 Kelvin. Okay, and you have rate constant. Rate constant is equal to how much? 2 into 10 to the power of minus 5. And the energy of activation is equal to 209.8 okay, kilojoule per mole for a reaction. Calculate the rate constant at 700 Kelvin. We have T2 is equal to 700 Kelvin, and I have to find K2 at this temperature. R value is given to me. Okay, so this question is from question number 42 of model question paper 1. Okay, now what we have to find here? K2. So we know this formula, log of K2 by K1 is equal to EA by 2.303 into R, right? R value is 8.314 1 by T1 minus 1 by T2. Right? Now if I substitute this all things, so how much I will get? So let's just do this one, log of K2 by what's the value of K1? Okay, EA value is 209800. I have converted this kilojoule to joule, so this is not kilojoule anymore. Okay, then 2.303 into 8.314. Okay, 1 by what is the T1 here? 600 Kelvin minus 1 by 700 Kelvin. Right, now if I solve this, I can find the value of K, which is equal to 8.14 into 10 to the power of minus 3 second inverse. Now I'm not telling you how to calculate because you have the calculator in the exam. You just need to calculate all these values and then you will be able to get this answer. Okay, now let's move to question number 5, okay, which is actually question number 46 in your model question paper 1. So analyze the given graph and drawn between the concentration of the reactant versus time in minute. Calculate the average rate of the reaction in terms of minutes and seconds. Okay, so we have to calculate average rate. So what is the formula of average rate? It is equal to change in concentration by change in time. Right, now suppose I'll consider this particular 10 to 20, this interval, if I, or let me just calculate 20 to 30. Okay, this interval if I calculate, okay, 20 to 30 interval. So at 20 it is 0.4 and at 30 it is 0.2, or you can take any interval, okay, because the interval is only 10 minutes. So let me just calculate this one. So 0.4 and here it is 0.2. So the difference will be how much? Minus of 0.2 minus 0.4, okay, divided by the time is in minutes, so 10. So that we will give here minus plus 0.2 divided by 10, so that is 0.02 moles, and we have minute inverse. Okay, now considering the average rate in seconds, so it will be 0.2 by 10 minute into 60 seconds. Okay, just you need to calculate this one, convert it this one. So you will get here 0.2 divided by 600, okay, which you can write it as 2 by 6 into 10 to the power of 2 and here 10 to the power of minus 1. Okay, now this goes up, so we will get 1 by 3 into 10 to the power of minus 3. Right, now this one 1 by 3 is how much? We'll get 0.333 something, right, into 10 to the power of minus 3, or if you can just further calculate it, you will get 3.33 into 10 to the power of minus 4. Okay, clear? Okay, next we'll move to question. This answer is actually incorrect. Okay, please don't check this one because this calculation is wrong. This one is the answer. Now let's move to next model question paper 2 here. So the first question is, for a reaction 2NH3 gives N2 plus 3H2, the rate is, okay. Now if you see that this is a surface catalyzed reaction, okay, decomposition of ammonia. It is a zeroth order reaction. So decomposition of ammonia, zeroth order reaction. So rate will be your option number D. It will not depend on the concentration of NH3. Okay. Next, write two differences between order and molecularity of a reaction. So this is question number 42. 2 marker questions in your model question paper 2. Okay. Oh, sorry, one second. Yeah. So model question paper 2, question number 21. Okay. Just a minute. So now let's see here. Molecularity is the total number of chemical species involved in the rate determining step, whereas order of the reaction is the sum of the powers of the concentration terms in the rate law equation. Next, it is a theoretical parameter, it is an experimental parameter. It is always a positive whole number. It can be positive, negative, 0 or even a fraction. Okay, it does not change with the change in temperature and pressure. It will change with the change in temperature and pressure. Okay, 3 points you need to write. The first 3 points are important. You can note down them. Okay, Next, we'll move to question number 3 here. What is meant by chemical kinetics, and give any two importance of study of chemical kinetics. Okay, so this is again your question number 34 in model question paper 2. It is a 3-marker question. So here you can see that chemical kinetics is a branch of chemistry which deals with rate of a chemical reaction, factors affecting the rate and the mechanism. Okay, that is the what is chemical kinetics. Now what information it gives us? It helps us to understand the speed or rate of a chemical reaction, and it also describes the condition by which the reaction of the rate the reaction can be altered here. Okay, now we will see the next question here, that is, just a minute. Now you will see the next question is again from like numerical questions. So the rate of a chemical reaction quadruples when the temperature changes from 293 to 313. Calculate the energy of activation of the reaction assuming that it does not change with temperature. So we have this formula again, one second, yeah, we have this formula: log of K2 by K1 is equal to EA by 2.303 R into 1 by T1 minus 1 by T2, right? These values are there. Now what I can do here is I can just substitute. Now it quadruples means K2 is 4 times of K1. So I can directly write here log 4. Okay. Next EA value I have to calculate. Then we have 2.303 into 8.314. Okay. Next we have 1 by T1 value is 293 Kelvin. And we have 1 by 313 Kelvin. Okay, so now we can solve this and calculate the value of activation energy. That will be equal to 52.85 kilojoule per mole. Okay, let's see the next question here. The carbon-14 content of an ancient piece of wood was found to have 3 by 10th of that of the living tree. Okay, calculate the age of the piece. Given values are, half-life is given, log 3 and log 7 values are given. So now see how to solve this question. So this is your radioactive decay question, first order equation you have to use. So let us assume that the initial concentration of this carbon-14 in the tree is C. Then what is the final concentration? It is 3 by 10 of the initial concentration, right? We got these two value. Now what is the first? We have to find the age, right? That means you have to find actually the time here. But what is the value of K? We have been given it half-life. So I can substitute 0.693 by T half, which is 5730. Now what is T here? T equal to 2.303 by K log of R naught by R. Okay, now if I substitute here, T will be equal to 2.303 by, what is the value of K? 0.693, okay, by 5730 into, okay, log of, what is R naught value? R naught value is C, okay, and then R value is 3 by 10, 3 by 10 C, okay. So now CC 10 by 3 it will become. Now here we will have 2.303 by 0.693 into 5730 into log 10 is 1 and log 3 is 0.4771. Now if I solve this, you will get the value of 9957 years. Okay, you can just calculate this one and check this value. Now let's move to model question paper 3. Okay, question number 9 was this one. For the reaction, the correct rate of the reaction is. Okay, so what will be rate here? If I write the differential rate, that will be minus 1 by 2 of dA by dt. Okay, will be equal to minus 1 by 3 of dB by dt is equal to plus, okay, plus, now see this 1 by 2 of 1 by 2, it will become 2 of dC by dt, right? Oh no, sorry, here also it is minus only because it is reactant, that is equal to plus dP by dt. Okay, now let's see, in all these equations we have minus dA by dt. Okay, so here too it is plus is there, so I think you can just check the first and second option. So minus dA by dt, if I just take this one, multiply this one here, so it will be minus 2 by 3 of dB by dt, and if I multiply this 2 here, then I will get minus 4 dC by dt, right? So yes, option A itself is the correct one. So here A will be the one answer. Next, again this question is the same question that was there in model question paper 2, already discussed. Okay, so not taking it again. This is question number 21 in model question paper 3. Now we'll go to this question, that is derive the integrated rate law equation for the zeroth order reaction. So this is your question number 33, 3-marker question. So this question is very simple, but I'll explain here, then I'll tell you how to write down also. So let's first understand. See, you have to assume any reaction, let it be A to B. Okay, and let us assume that it is a zeroth order reaction. Then what will be the formula of rate? It is equal to minus dA by dt. Okay, and I can also write rate is equal to K into A. Okay, zeroth order, so this will become 0, so that is K. Now rate, the left hand side is equal here, so I can write minus dA by dt is equal to K. Okay, now you can cross multiply here, minus dA is equal to K dt. Okay, now take integration on both sides. Okay, so if I take integration on both sides, that will become A, okay, minus A is equal to KT plus I. Now I is the integration constant. Now our task is to find the value of I. Okay, so at t equal to 0, at time t equal to 0, what I can calculate? Minus A naught. So A value will be A naught here. Okay, so this is minus A naught. Okay, K, this is 0 plus I. Okay, so I value is equal to minus A naught. Clear? Now I can substitute here this value, minus A is equal to KT plus I value is how much? Minus A naught. Now this A naught value comes here, A naught minus A is equal to KT. So this is my final integrated equation for the zeroth order reaction. Okay, so that is how you can note down this one. You can just check how you have to frame the answer, how to write down the equation, that you can see here. Okay, moving to the next question. Again we'll come back to numericals now. First order reaction has a rate constant of this much. Okay, this much at 500 Kelvin. At what temperature the rate constant of the reaction becomes this much? At what temperature? EA value is given to us and R value is given. So we have to use the same formula, log K2 by K1 is equal to EA by 2.303 R into 1 by T1 minus 1 by T2. Right, just substitute here. So what is the value of log written? K2 value is how much? Now see, this is the higher temperature, right? K2 value is 17.25 into 10 to the power of minus 4, and K1 value is 2.3 into 10 to the power of minus 5. Okay, that is equal to EA value is how much? 1911472. Okay, 2.303 into 8.314. Now 1 by T1 is how much? 500, and 1 by T2. So we have to solve this equation and then have to find the value of T here. Okay, so now you can see that how can we solve? You have your calculator, so just solve this first and then calculate this value, and if you calculate you will be getting temperature as 572 Kelvin. Okay, so you have calculator. I'm not going in detail how to calculate this one, but yes, you can easily do it using calculator. Next question of first order reaction has a half-life of 23 minutes. Okay, so half-life is 23 minutes. Okay, next what we have, how much time will be needed for 30% completion of the reaction. Okay, now if 30% of the completion of reaction, what is K value? It is 0.693 by T half, which is 23. Okay, so I can write K value is minute inverse. Now the A value, what is the initial concentration? It is 100. Okay, now if 30% of the reaction is completed, then what is the A value? It is 70. Okay, so now we have what I have to calculate here, time. So time is equal to 2.303 by K log of A naught by A, right? So what I can do, 2.303 by what is the value of K? 0.693 into 23, right? This goes up. Then I have log of A naught value is 100 and A value is 70. Now you just need to solve this value, and once you calculate, you will get 11.84 minutes. Okay. Now we are done with the model question paper questions. Now let's see some question from question bank, the revised new question bank of 25-26. So the first question here is the question number 6. Okay, so this is a 2-marker question. So here you have to find the order of the reaction with respect to A and B, and you also need to write the overall rate equation. Okay, so now you can see here how to do this question. So let us assume this is the reaction, right? So you have to assume that the rate is equal to K into A to the power of X and B to the power of Y. Let us assume this value. Okay, now what I can write here, the values here, R1 will be equal to 0.5 K into 4, which is A, X, and 1 to the power of Y. Now we have R2 is equal to 0.5 K, and we have 4 to the power of X and 0.5 to the power of Y. Now we have R3, which is equal to 0.25, okay, K, and I have here 2 to the power of X, and I have 0.5 to the power of Y. Okay, so we have to now calculate this X and Y. So now what I can do is to calculate X, okay, I need to have Y constant, and that I can have in R2 and R3. So let us first find X. To find X, okay, to find X, what will happen? You can just divide these two equations, I can say we can divide R2 by R3, okay, that is equal to 0.5 by, so I can write 5 into 10 to the power of minus 1 by 25 into 10 to the power of minus 2, okay, is equal to K over and 4 by 2, right? So it is 2 to the power of X we will get. Now we can solve 5 ones are 5 5s are. This goes up, it becomes plus 2. So 2 minus 1 is 110, and you will get 2 equal to 2 to the power of X, and we have X is equal to 1. So for now we have found the value of X, and I'll write that here, X is equal to 1. Now next part is what? To calculate the value of Y. Okay, so I will find the value of Y here. How can you find that? That is also very simple. See, to find the value of Y, you need to have X constant, and X is constant in 1 and 2, right? So take reaction 1 and 2, R1 by R2, okay? So that is equal to 0.5, 0.5, okay? Then you have K4X, K4X, and you have 1Y, okay? Then you have K4X and 0.5Y. Okay, now here if I solve, these all things can get cancelled. So I have 1 is equal to I can say 10 by 5 or 5 by 10, this becomes 10 by 5. So it is 2 to the power of Y, right? I can write like this, 1 by 0.5, that can be to 5 by 10, so goes 10 by 5. And if I cancel 2 to the power of Y, so I'll get 2 to the power of 0 is equal to 2 to the power of Y. Now Y is equal to 0 here. So I will get here Y equal to 0. Okay, now I can solve x, I can solve y also. So what is the order with respect to a and b? So you can write down the order with respect to a, that is x, it is a first order, and with respect to b it is a 0 order. Now what is the overall rate equation? So the overall rate equation is equal to r, a is x is equal to 1 and b 0. Okay, clear? So that is the overall rate equation. Now let's move to the next question. For a first order reaction, plot the graph of, so 1 second. Okay, question bank, right? So I'm just discussing questions from your 2 marker section. Okay, so for a first order reaction, plot the graph of log r0 by r versus time and write the value of slope for this graph. Okay, so this question is there in question number 11 of question bank 2 marker section. Okay, so now if you see here, if I okay, just a minute. Okay, so let's write down the equation first. What is our equation? Kt is equal to 2.303 log of r0 by r, right? This is my equation. Now I have to plot a graph for log versus time. So let's keep log on one side and time on another side. Okay, so your y axis should be log r0 by r and x axis has to be t. So I can write this equation like this: log r0 by r is equal to k by 2.303 into time. Okay, so now this we have y is equal to m into x. Okay, so now let us try to draw the slope here, or let us try to draw the graph here. So what is this one? This is log of r0 by r. Okay, and this is time. Okay, so we have slope is a positive slope, and the slope, there's no constant here, so it is a positive slope passing through the origin. So it will be a graph like this, and the slope here will be k by 2.303. Clear this one? Okay, next we'll move to the following graph. Shows half-life, that is T half versus initial reactant concentration and reactant. So half-life is there and initial concentration is there. What is the order of the reaction? So if you see, for 0th order reaction, what is the formula? T half is equal to A naught by 2K. So what you see here, T half is directly proportional to A naught. So as the initial concentration, as the concentration increases, T half increases. So what I can say, the order of the reaction is a 0th order reaction. Now what is the unit of this K? So for the unit of K, the general formula is what? K formula is equal to moles to the power of 1 minus n liter n minus 1 second inverse. Now if I substitute 0 here, it will be mole liter minus 1 and second inverse. So what I will get here? Mole, okay, liter minus 1 and second inverse. Clear? Next, we have what happens to the half-life of a first order reaction when the temperature is increased. Give reason. This is question number 17 from question bank. Okay, so what happens to the half-life when the temperature is increased? Now see, what is the formula of T half? So first let's understand. T half formula is 0.693 by K, right? When temperature increases, K value increases. If K value increases, then T half value will decrease, right? So that is the reaction. The half-life of a first order reaction decreases as the temperature is increased. Okay, well, how will you explain this? This happens because a higher temperature leads to a greater rate constant, which accelerates the reaction and reduces the time it takes for the reactant concentration to be half. Now when the rate of the reaction increases, the concentration reaches to its half concentration in a smaller span of time, so half-life will be reduced. Next, plot the Maxwell-Boltzmann distribution curve and marks the position of EA. So you can see this is the graph Maxwell distribution curve, and here you have to mark the position of activation energy. Okay. Next, illustrate graphically the effect of catalyst. So this graph is also very important. Without catalyst, the graph is like this. With catalyst, the activation energy decreases. The dotted line versus with the catalyst. Next, graphically represent Arrhenius equation and how do you calculate the activation energy from it. So if you have the Arrhenius equation is like this. See, K equal to A into e to the power of minus EA by RT. Now ln K is equal to ln A minus EA by R into 1 by T. Okay. Now here we have what? We have Y C minus M into X. Okay. So here I have 1 by T and then I have minus EA, that is the slope, minus EA by R, and then you have Y intercept ln A. Okay. Next, the question is derive the integrated rate law for the first order reaction. So this one first I want to explain you in simple terms like we have done for zeroth order. It is very similar to that. Okay. Now see, if you see for first order, let the reaction be like this, A to B, right? So what is rate here? Rate is equal to minus dA by dt. Okay. And I will have rate is equal to K into A. Right. Now these two I can equate, minus dA by dt, okay, is equal to K into A. Okay. Now minus dA by A, okay, is equal to K dt. Right. Now I can take integration on both sides. So minus dA by A is equal to what? Minus log A. Okay. So it is actually ln A. You will get here, just a minute, minus dA by A, you will actually get ln of A. Okay. And here I will get KT plus I. Right. Now the next thing is to find the value of I. So what we have to do for that, you have to assume that at at time equal to 0, A value is equal to A naught. Right. So substitute here, minus ln of A naught is equal to K into T. T is equal to 0. So that is equal to I. Oh, sorry. Just a minute. Okay, I'll explain here only. I think I missed that. So see here. So minus dr by r, you will got ln r minus kt plus I. Next thing is to find the value of I. So you have to find, you have to substitute t equal to 0, and at t equal to 0, we have r is equal to r naught. Right. Now if I substitute that, I will get I is equal to ln of r naught. Clear? Now you can substitute this in the equation. Ln of r is equal to minus kt plus ln of r naught. Now what I can do, kt I will take on one side, this one I can take on one side, and if I multiply, you will get kt is equal to ln of r naught by r. Now to remove this ln, you can multiply 2.303 log 10 r naught by r. Now finally you can just equate this one, you will k equal to 2.303 by t log of r naught by r. Okay. Next, what is the effect of catalyst on a reaction with respect to the energy of activation, delta G of the reaction, time required for 50% of the reaction to be completed. Now see, here if you see that, okay, now energy of activation, when catalyst is used, okay, when catalyst is used, what happens? EA, sorry, you have just seen the graph that for catalyst we have the EA value is reduced. Okay, if EA value will be reduced, then K value will increase. Okay, K value will increase. Why? See, what is the Arrhenius equation? K equal to A into e to the power of EA by RT. Right. Now see, if this EA value is reduced, this whole term is reduced. If this whole term is reduced, then K value has increased. Okay. Now for the second one, you see in delta G there is no effect or no change. Okay. Delta G equilibrium constant, there is no change. Next, time required for 50% of the completion, 50% of the reaction to be completed. Now see, T we will consider, for example, as for a first order reaction, what you will see that K value, okay, for any reaction, if K value is increased, for zeroth order it is A naught by 2K, T half formula, right? For T half for first order is 0.3 693 by K. So if the K value has increased, then what will happen? T half will decrease. So what will be the effect on T half? It will decrease. Okay, so that is how you can write this answer. Next question will go to now 3-marker questions. If a homogeneous catalytic reaction can take place through 3 alternative paths as depicted below, the catalytically efficiency of PQR respectively, which reaction path proceeds easily or faster? Give reason. See, wherever you have less activation energy, that will be proceeding faster. So you can see here, if I draw the activation energy, okay, activation energy for R is this one, for Q is this one, and for P will be this one. So since the activation energy of R is least, it will proceed faster. Okay, so you can write down, since the activation energy of R is least, it will proceed faster. Okay, it will proceed faster. Clear? Next, we'll do some 1-marker questions. Okay, so these are actually some HOTS question. Okay, that I have taken from certain publication books. So the first question here is 2N2O5 gives 4NO2 plus O2. Okay, here 2 is missing. For the above reaction, which of the following is not correct above rates of the reaction? Okay, so minus dN2 by minus D. Okay, so what is the rate I can write? See, rate will be equal to minus 1 by 2 of dN2O5 by dt, right, is equal to 1 by 4 of dNO2 by dt is equal to dO2 by dt. Okay, so minus dN2O5 by dt will be 2 times of dDO2 by dt. This statement is correct. Now next one, N2O5 and NO2. So if I see dNO2, okay, which is the correct, right? The first not correct, the question asking not correct. Okay, this is correct. Now let's see the second one, minus dN2O5 by dt is 4 times of dO2 by dt. Okay, 1 second. Okay, here's a small typing error. This is dNO2. Okay, so minus dNO2 by dt is 4 times of dO2 by dt. This is also correct. Next is what we have done. Minus 2 dN2O5 by dt is equal to 4 NO2 by dt is equal to O2 by dt. No, this is actually wrong. This statement is wrong. Okay, it is the inverse should be taken. So option number D is the incorrect one. Okay, and here the question has been slightly, this 2 is not there. Okay, so minus dNO2 by dt is equal to minus 2 of dN2O5 by dt. This is also correct, option number D here. Next, you have to consider the following statements with respect to zeroth order reaction. The rate of the reaction is independent of the reactant concentration. Obviously, it is a zeroth order, that is why. The rate of the reaction is independent of the temperature. No, it is dependent on temperature. The rate law expression and the unit of K is second inverse. Okay, the unit of K is second inverse. No, it is not second inverse. This is incorrect. The rate constant of a reaction is independent of the reactant concentration. Yes, that is also correct. It doesn't depend. Now choose the correct statement. So we have 1 and 4, which is option number D. Okay. Next, for a first order reaction, the time required for 99.9% of the reaction is equal to, this we have derived many times, it is 10 times of the half-life. You can check, you can verify this one, or you can even remember this result. It will help you to do easy calculation. This results you should remember. Okay. Next, when initial concentration of the reactant is doubled, the half-life period of a zeroth order reaction is, see, now the half-life of a zeroth order formula is what? A0 by 2K, right? So when the initial concentration of the reactant is doubled, the half-life period of a zeroth order reaction. So if this is also double, it will become 2 of A0 by 2K, right? That is 2 times of T half. Okay, it becomes 2 times of T half, right? So that is, it is doubled, so option number B here. Next, for the chemical reaction N2 plus 3H2 gives 2NH3, the correct option is, so what is the correct option here? So we can write down minus dN2 by dt, okay, is equal to 1 by 3 dH2 by dt, okay, then I have plus 1 by 2 dNH3 by dt. Okay, so now here the correct option is dH2 by dt will be 3 by 2 of dNH3 by dt. This option is wrong. Minus 1 by 3 of dH2 is 1 by 2 of dNH3. This is correct. Okay, dH2 by dt is 2. No, it will become 3 by 2. This is also incorrect. Minus dH2 by dt will be minus H2 and NH3, right? So this is also 3 by 2. So this is also incorrect. Option number B is the correct one. In collision theory, chemical reaction ZAB represents, it is representing the collision frequency, right? So that is option number C here. Next, the reaction enthalpy of the reaction is minus 4.2 kilojoule per mole and enthalpy of activation is 9.6 kilojoule per mole. The correct potential energy profile for the reaction is shown in the option. Now see, when it is minus 4.2 kilojoule, that means it is an exothermic reaction. Heat delta H is negative, that means energy of the product is less than energy of the reactants, right? So here if you see, if I draw the graph, see, this is the energy of the reactant and this is the energy of the product. So this is energy of reactant is more than that of the product, so this is wrong. Next, this can be correct, okay, yes, this is the only option where I have this delta H condition satisfied. Other two options are also wrong, so option number B here. Next, the given graph is a representation of kinetics of the reaction. So y and x axis are y and x axis for zeroth and first order reaction respectively are, okay. So y and x axis for the zeroth order, what it can be, okay, y can be rate and x can be concentration. Yes, that is correct. See, rate will not be affected on concentration, so y can be rate and x can be concentration and it will be a straight line. So this y rate x concentration is correct, y rate x concentration is correct, y concentration x time, this is different, this is also different. So I can have A and B. Now for first order reaction, y is equal to T half and x is concentration. Yes, definitely. For first order reaction, you know T half is equal to 0.693 by K, means T half does not depend on concentration. So with concentration, it will remain constant. So y is equal to T half and x is equal to concentration. That is option number A here. Next, which of the following method is used as a trial and error method to determine the order of the reaction? So that is your integrated rate law. You have to substitute the values and check again and again. Next, for a reaction A plus B gives you C plus D, it is found that the concentration of the reactant is taken as excess and concentration of A is increased by 4 times, the rate is increased by 2 times. The order of the reaction with respect to B is, okay. When concentration of reactant B is taken, see, now when B is taken in excess, that means B is not affecting the rate of the reaction. So with respect to B, it will be a zeroth order reaction. This is an example of pseudo first order reaction, okay. Now let's solve some numerical questions, okay, which is your 3-marker questions. So in a chemical reaction, A plus B gives you C plus D. The concentration of A alone is increased by 2 times, the rate is increased by 4 times. If the so let me just write down. We have a reaction like this. 1 second. Yeah, A plus B gives me C plus D. Okay. Now what is rate here? Rate is equal to K into A to the power of X and B to the power of Y. This is the rate equation. Okay. Now the concentration of reactant A alone is increased by 2 times and the rate is increased by 4 times. Okay. So what happens here is, the condition is saying that if the concentration of A is increased by 2 times, okay, then the rate will become or increase by 4 times. That's the first condition. And if the concentration of A and B both are increased by 2 times, the rate is increased by 8 times. Okay. I have both is increased by 2 times, then the rate is increased by 8 times. Okay. Now what is the thing you have to find here? We have to find X and Y. Okay. So let us first compare these two equations. Okay. So if you compare, this wall will get cancelled, or I'll just suppose this equation 1, equation 2 and equation 3. Now let's divide equation 1, equation 2 by 1. Okay. So what I will get here, you see everything will get cancelled. You will have 4R by R is equal to 2x, 2x you will get, right? So that will get x will be equal to 2. Okay, x will be equal to 2 here. That is done. Okay, next is we have to find y. So let us take equation 2 and 3, or divide 3 by 2. Okay, so if I divide 3 by 2, it will become 8 by 4. Okay, now this all things will get cancelled and you will get 2 to the power of y. Okay, 2, 1 and 2 y. So you will get y is equal to 1. Right, so x2 and y1 you will get. So I will get r is equal to k a to b1. Okay, r k a to b1 we will get the value. Clear? Okay, let us see the next question. In a zeroth order reaction, the time required taken to complete the reaction from 100 to 50% is 40 minutes, right? So I can write here the T half value is how much? 40 minutes. Okay. Now what is the time required for the concentration of the reactant to go from 25 to 12.5? Now remember, this is a zeroth order reaction. Okay. Now see, 100 to 50. Okay, first we will go. Then 50 to 25. Then 25 to 12.5. Okay. Now this value is 40 minutes. Right. 100 to 50 is 40 minutes. Now what we can calculate here? See, we have this formula that I can write T half is equal to A naught by 2k, right? Here what is the value of, I can find the value of k here, that is A naught by 2 into T half. Okay, A naught is 100, 2, T half is 40. Okay, so I will get k value is 5 by 4. Now from 25 to 12.5 if I want to go, what's the formula here? A naught minus A is equal to K into T. Okay, so A naught value is how much? Here 25. Okay, A value is 12.5, right? Then K value is 5 by 4 and time I have to calculate. So that will give me 12.5 into 4 by 5 equal to T. So you can just calculate 2.5 you will get, right? And this is 25 is equal to 10. So time you will get here is 10 minutes. Okay, so what will be the answer here? 10 minutes. Okay, clear? Next question number 3. Calculate the time in seconds for the decomposition of nitrogen pentoxide which follows first order kinetics when the concentration of N2O5 is dropped from 0.1 to 0.01. So again, same formula, it's a first order reaction. We can directly calculate T is equal to 2.303 by K value is 6.22 into 10 to the power of minus 4. Okay, just 1 second. Yeah, you have seen the answer is already 10 minutes. Okay. K 2.303 by this one log of A naught by A. So that is 10 to the power of minus 1 by 10 to the power of minus 2. So this goes up. So just you need to solve this value and you will get here 3.7 into 10 to the power of 3 seconds. Next, question number 4, for a first order reaction, show that the time required for 99% completion is twice the time required for 90%. You have to prove this one. Okay, so let us do this one. So first let us solve the LHS one. Okay, so here time I want to complete 99%, right? So that is equal to 2.303 by K log of 100 by 1. Okay, so you will have 2 into 2.303 by K. Okay, now here I have RHS value. RHS value is 90%, T 90%. Okay, that is equal to 2.303 by K log of 100 by 10. Okay, and that will give me T90 is 2.303 by K. Now you can see here that I can write 2.303 K is nothing but T90. So I can write T99 is equal to 2 times of T90. Okay, that is proved hence. Next, T half of a reaction is 10 minutes for a first order reaction. What percentage of the reactant remain unreacted at the end of 50 minutes? Okay, so let us first find the value of K here. It will be 0.693 by T half, which is your 10 minutes. Okay, now the question is, so we have this value K equal to 2.303 by T log of A naught by A, right? So you have to find this value of A here. So how can I find? K value is 0.693 by 10, okay, 2.303. Now time value is how much? Time value is 10 minutes, right? No, the question is asking for 50 minutes, right? So I'll have to write here 50. Yes, 1 second. Yes, 50 log of A naught value by A. So we have to, what percentage of the reactant remained unreacted? So let us just find this fraction A naught by A. Okay, so how to calculate this one? I can cancel 0, 0 here. I can take this multiply 5 here. So I will get log of A naught by A, okay, is equal to 0.693 into 5 by 2.303. Okay, so that will be equal to, like, 5 3s are 15, 5 9s are 45 plus 1 46, 4 5 6 are 30 plus 4 34. 303. Yes. Now if I solve this, how much I will get? So let us divide this. You can use calculator easily here. Now if you solve this, you will get a value of 1.5. Okay, now I can say that A naught by A will be equal to how much? It will be equal to 10 to the power of 1.5. If you take antilog of this one, you will get somewhere around 31.6. You can use antilog table. I have made a detailed video on how to use antilog table. You can see that. Okay, now I want the fraction, so I need A by A naught, okay, into 100. That is 1 by 31.6 into 100. If I solve this, I will get 3.125%. Okay. Now next, a first order reaction takes 40 minutes for 30% decomposition. Calculate the T half. Very simple question. First of all, you need to calculate the K value here. That is 2.303 by T is 40 minutes log of 100. 30% decomposes means 100 by 70. You will get the K value here. Now how to calculate T half from here? That is 0.693 by whatever K value you have calculated here. So K value after calculating will be somewhere around 8.9 into 10 to the power of minus 3, and your T half value will be 77.7 minute. Okay. Next, the graph of log K versus 1 by T for a reaction is linear with intercept of 10, okay, and slope of this one. Calculate the frequency factor and the EA of the reaction. Now what is the graph we have? Log K is equal to log A minus EA by 2.303 2.303 R into 1 by T. Okay, so this is Y, okay, this is M, this is X, and this is C. Now what we have to find out here, intercept of 10 means this C is this one, okay. So log A value is 10, right? Then what is the value of A here? Antilog or 10 to the power of 10. This is the value of A, done. And slope is given to me, which is EA by 2.303 R. So we have calculated the frequency factor and EA of the reaction. So what is the value of EA by 2.303 R? That is equal to how much? Minus 5.1 into 10 to the power of 3. Okay. Now what is the value of EA here? That is minus 5.1. Okay. Here one thing I'll tell, this is also minus, this is also minus, so you can cancel. 5.1 into 10 to the power of 3 into 2.303 into 8.314. Now if you calculate this one, you will get the value of EA. Okay. So let's see what you will get. Yes, A value is 10 to the power of 10. EA will be 97.65 kilojoule. Okay. Next, the rate constant of a reaction at 500 and 700 Kelvin are this and this. Calculate the energy of activation. This is also a very simple question. You have log of K2 by K1, right? What is the value of 0? So K2 is 0.07 and this is 0.02. That is equal to EA by 2.303 into R is 8.314. 1 by T1 is how much? 500, right? Minus 1 by 700. If you solve this, you can calculate the value of EA, which will be around 18.228 kilojoules. See, these all are based on calculations using calculator. You can easily do, so no need to explain here calculation. This is simple maths here. So students, this was the most important questions from this chapter. You have to focus on integrated rate law and half-life, order and molecularity in the sample model question paper, also questions there. And yes, Arrhenius equation, numericals is very, very important, and all the graph of this particular chapter you should practice thoroughly. Okay, I have given you many graph questions, you can do that, and also more questions you can practice. Okay, so thank you so much and all the best, and I hope this session was helpful. Any further doubts you have, please put down in the comment section. I'll definitely address to it. Thank you.